G'day everyone, this is Medan's Art, and today I have a rather unusual video for my channel, but I felt the necessity for this video. And what we're talking about is the citizen science page Zooniverse, and in particular the project of Exoplanet Explorers K2. So I hope that you're overall familiar with the Zooniverse page itself, because I really want to just make a tutorial specifically for Exoplanet Explorers. Now, chances are that you have to look at hundreds of light curves before you find one good example of a planetary candidate, such as this one we have here, which is from a recently confirmed planetary system K2 38, and this is planet D, so it's the third planet of the system. And there's a lot of false positives who look very similar but are no planetary candidates, in fact. And so I would just want to show you some of the most common ones and give you some tips what to look for if you want to make sure that it's not a false positive. Now, the first big group we have are eclipsing binaries. Now, in our galaxy, most stars are part of a binary star system, so we get them quite often, but we're not looking for them. One big giveaway sign is that they usually have a secondary eclipse somewhere in the light curve. Now, for the most part, you see the secondary eclipse somewhere in the folded light curve at 0.5 or somewhere in this area between 0.4, 0.6. Usually you find a secondary eclipse which can be larger or smaller. Sometimes it's actually a gap that is, as you can see in the bottom right, where the primary eclipse has been removed from the light curve, and so there's just a data gap. But it's still a giveaway sign that this is an eclipsing binary. What can happen sometimes is that the computer program folds primary and secondary eclipse onto each other. That's what you see in the top left. And in this case we actually have the secondary eclipse, which is the smaller one, is still in the data, and the primary eclipse has been removed, so you don't have a data gap. Every second transit that this the individual transits show is actually a data gap, so another giveaway sign that this is an eclipsing binary. If this primary eclipse is not removed, you usually get transits with different depths in flux. You have the primary, which is a little bit deeper, and you have the secondary, which is a little bit more shallow. Another good indication that it is an eclipsing binary is usually the number of transits. When you have something like bottom left, which has a whole lot of transits, yeah, it's probably usually not a planet. That means that it's a very close binary star system. And now these four candidates are pretty obvious. There are, however, other eclipsing binaries or things that could be both. I cannot clearly say it, for example, for this particular one. I think I actually said it is an eclipsing binary, but you can have these. This one has no clear secondary eclipse, and it's the only giveaway sign for this one is actually the drop in flux, or the drop in brightness, which is 0.08, which is I think 8% drop in brightness, which is a bit too much if this would have been a planet. You can have these systems where you have a big Jupiter orbiting around a very small star, then you can have these kind of dips, but usually that's too much for a planet transit. So another thing you have to be aware of are these, I would call them glitches, where you have a single data point which just drops out of the light curve and creates a fake signal. The example that we have here is pretty obvious. You have these two data points that just completely fall out of out of the light curve, and the computer program just thinks, oh, maybe that's a transit, but in fact it's not. It's just an error. Another thing that can happen sometimes, and I think it has to do with the movement of the Kepler telescope itself, that certain data points are not properly connected in the light curve, and the example that you see here, especially the last transit, is kind of showing this. You have this huge gap between two data points, and this creates this dip. Now in the zoomed folded transit, this looks actually like a pretty good transit, especially when you have two of these gaps that are on opposing sides, or when the cliff is on the opposing sides of the transit. You actually get a very good signal in the zoomed folded transit, but in fact it's fake. It's not real. So always take a look at the individual transits. Sometimes they give away that this is not a real signal. Another thing that you should pay attention to is how the folded light curve looks. If there are regular patterns in it, it's most of the time it's a strong giveaway that this is not a transit. For example, if you have a kind of a sinus curve or a saw blade pattern in the light curve, that usually means that that you have a variable star who created the signal of this potential transit, and not an actual planet. So what are we actually looking for? Here we have 4 confirmed planets, so this is these signals are real. On the left we have K2 138, which was just recently it's just a recently confirmed planetary system, and on the right we have K2 133. And what are some good signs that these are actually planetary candidates, or in fact confirmed planets? Now the first thing is we have in the individual transits, each individual transit follows more or less this U-shape pattern of a planetary transit. Another thing is that the dip itself is actually very small. We're talking about a drop in brightness of 0.01 and less. And when you look above the light curve, there's very few data points. Usually there's maybe 1 or 2 at best that are above the light curve in this area of the transit. And as a last tip, when you're looking on the bottom right of the subject, you will find a little help icon. And when you click on this help icon, you have this small window where you have this link, which leads you to the page Exofob. So you can open it in a new tab, and on this page Exofob you get some information about the star. It's mostly about the star. In this case it's actually again the confirmed planetary system K2 138. So in this case Exofob tells you, okay, we have a confirmed planet, or more in this system. It even gives you the numbers of these planets, so in this case we have 5. When you scroll down a little bit, you find the star parameters, where you can see what radii the star has compared to the Sun, and what mass compared to the Sun. And if you need some further help to decide whether it is a possible planetary candidate or not, this really depends on if you have, for example, a very deep dip of 0.1 or something, and you have a very big star. It's very unlikely that this is a planetary candidate. Just the size comparisons really matter in that case. But if you have a very small star, it's actually possible that this is a transit, maybe from a hot Jupiter or something, who's orbiting a very small star. So in these cases you can look at Exofob, and it can give you a lot of information. And sometimes when it's already confirmed that this is a binary star system, it is saying this in top left, where there's in this case it says confirmed planets, it says a possible binary star system. I think it would, or eclipsing binary, something like this. So I think that's it for this tutorial. If you have any advice or any corrections or anything, just write it in the comments. And I will also put a link to Zooniverse, the Zooniverse page into the description for those of you who haven't seen this page yet, haven't visited it, and are eager to find out what you can do there.